we are going to start the lecture on nanotechnology and chemical engineering. So, today we will discuss various type of or special type of carbon nanomaterials. So, that is carbon nanotubes. So, that we will discuss. So, in our previous class we have discussed fully range, carbon nanomaterials. So, up today we will discuss carbon nanotubes. So, what are carbon nanotubes and type of carbon nanotubes, what are the different type of carbon nanotubes are present, and then synthesis of the carbon nanotubes by considering different methods. So, different methods, electric arc discharge, CVD, laser ablations, these are the methods already we have discussed in our previous lecture. So, then growth of the mechanisms and properties of these carbon nanotubes and applications of this carbon nanotubes. So, these are the things we will discuss. So, already we said that carbon nanotubes that may be single wall, multi wall or double walls carbon nanotubes. So, that is the different allotropes or carbon nanotubes is formed. So, what are the carbon nanotubes actually that is formed? So, here you can see it is started with the carbons elements. So, that hexagonally arranged and then it can form a sheet. So, when this sheet is folded at particular angles, so then it may be rolled and then it can form or give a tube like structure. So, then we can say that it is carbons made of carbons and the carbon atoms hexagonally arranged form a sheets, and then when it is rolled a cylindrical type of structure is formed. So, then we can say it is a carbons nanotubes. So, these carbon nanotubes may be singles wall or maybe double walls or maybe multiples walls also, multiples wall formations is there. So, then we can say depending upon the number of tubes. So, we can categorize it as either it is single wall carbon nanotubes, double walls, multiple walls, more than one walls or tubes huge or tubes formations is there when it is formed. So, diameter usually single wall carbon nanotube that is 1 to 2 nanometers, and in case of the doubles or multiples walls. So, then diameters of these tubes that gradually increase. So, it is 2 to 25 nanometers, within that range we can say. So, usually these carbon nanotubes it is 1D type of one dimensional materials. So, that was actually accidentally observed in the year 1991 by S. Izima. So, then by using TEM analysis or transmission electrons microscopes under that. So, it was discovered, and then it is actually forms of carbons and hexagonal type of sheets, hexagonal arrangements of the carbon atoms form a graphitic sheets. Okay. So, when it is concentrated more than one carbon nanotubes, so then it forms a multiple carbon nanotubes, and carbons nanotubes it is a sets sp2 type of bonded or hybridized, and carbon single wall carbon nanotube that is very difficult to forms, and however, when it is multi walls, so multi walls carbon nanotubes easily we can forms, and once we forms multi wall carbon nanotubes that can be converted into single wall carbon nanotubes by exfoliations or etching methods. We can convert that multi-wall carbon nanotubes into single wall carbon nanotubes. So, the diameters I said, so it is 1 to 2 nanometers when it is single wall, and when it is multi walls, so then 2 to 25 nanometers within that range, and the length of the tube, so that is 100 to 1000 nanometers in that range, and distance in between two walls that is 0.334 nanometers, very small, less than 1 nanometer. So, distance in between two tubes. Okay. And next is this, when it is forms, I said the tubes are normally terminated with hemispheres of fullerenes. So, this part of this sections here hemisphere type of means ends or this place it is formed. So, here and cap you can say or end caps. So, here hexagonals as well as pentagonals type of carbon arrangements is there when this place. So, it is this carbon nanotubes I said like fullerenes, it is also non-polar in nature, and that is highly insoluble in water. So, easily we cannot dissolve insolubles in water. So, it is not soluble. So, if we functionalize that nanotubes by using different acid or alcohol groups may be forms, and then they can be dissolved or means solubles by some chemical reactions or oxidizing effects. So, then chemical oxidization we can functionalize these acid groups, alkyl groups, and then we can convert from one particular means CNT structure, CNT with functional groups from to another we can form. And next is the means chemical properties that already said. So we can say that acid groups, alcohol groups we can mix with that carbon nanotubes. Also fluorines also, that also can be fluorinated with that carbon nanotubes, that can be forms. Here's for acid attachments with the carbon nanotubes. So here some electrophilic compounds also, means dichlorocarbons, that also can be functionalized with the carbon nanotubes, or also by flowing fluorine gas also is also easily fluorinated these carbon nanotubes at low temperatures. We can make different functionalizations. So here you can see that we have started with CNT, then we can treat it with acids, and then acid functionalizations is there, and then we can convert by using with these chlorinations, and then amines we can also, this type of amide means functionalizations can be formed or possibles, or even by treatments with this acid with alcohols, then this type of ester functionalizations with these carbon nanotubes, or this type of modifications is possibles. Even I said that single wall nanotubes we can take, and if we pass it to gas, fluorine gas, so then fluorine functionalizations is possible, and then once it is fluorine functionalizations, then this type of Grignard reagents we can use alkyl magnesium halides groups, and then alkylations means these alkyl groups also can be inserted, or functionalizations can be possible with the nanotubes. Then types of single wall carbon nanotubes. So that it is said that carbon, that is sp2 hybridations, and graphitic sheets that is folded into cylindrical shapes. So here the carbon nanotubes we can different type of carbon nanotubes is formed. So here that depends, here depending upon its chirality or angles of the way it is folded. So that way we can consider it is zigzag, armchairs, or helical type of CNT. So when it is zigzag type of arrangements of the carbon atoms, so here the angles that would be theta equals to 0, and chirality that I will discuss. So A0, or when it is armchairs, here's theta, that is way it is folded. So theta equals to pi by 6, and chirality is AA, then it is armchair type of single wall carbon nanotubes. Structure formations is there when it is theta equals to 0 to pi by 6, and chirality is AB type. So then a helical type of CNT formations is there. So here the theta and chirality, so depending upon that, so this different type of 3 different way or categories carbon nanotubes we can classify. So here when zigzag type of or achiral type of carbon nanotubes formation is there, their R is A0 and theta is 0, and when it is chairs achiral, so here R is AA and theta is 30, and when it is helicals, so AB R and theta 0 to 30 within that range. Okay. So here I said that the carbon nanotubes that is forms, so hexagonal way of arrangements of the atoms. So carbon is, it is graphitic sheets, and carbons is sp2 hybridations, and it is hexagonal way of arrangements of carbons in this carbon sheets or graphitic sheets. So here each carbon sheets are hexagonal way of arrangements of carbon, or each hexagons we can identify, and then that would be each hexagons we can use by this way A and B, that is particular locations. It is AB is allowed, BA is not allowed. So this is theory, actually it way it has been proposed. So here's A and B is the chiral length of vectors R. Okay. So R is the vectors, and A and B both are the chiral length. So here's R equals to AX plus BY, where X is the square root of 3D and Y is square root of 3D, where D is the distance of each carbon to carbon distance. So here you can see, here this is the AB and this is X and this is Y. So in between AB and X, the length or angles, that is the theta, and R equals to AX, that is the vectors. AB are the chiral's length and R is the vector. So we can express this way, and the theta angles of this, that would vary 0 to pi by 6 within that range, the theta value. So, here the tubes, whatever the tube is forms means carbon nanotubes. So, its diameters we can find out by using d equal to circumference of the tubes divided by pi, has circumferences, that is equals to r, that is mod r. So, that we can express this way, and here r equals to this, we can substitute here this, and then where x equal to this and y equals to this. So, if we know the a, b and carbon to carbon distance, so then the diameter of the tubes we can find out. So, here this formula we can use to find out the diameter of the carbon nanotubes, also the angles I said. So, that angles also we can find out by using this. Here theta equals to cos inverse, and this here AB arterial length if you are possible to know. So, then these are the theoretical studies. So, then the angles we can find out, angle theta, and diameter of the tubes we can find out, and depending upon this angles theta, it's either which type of forms carbon nanotubes, either it is zigzag features or helical type of carbon nanotube formations is there, so that we can classify or we can categorize that type of carbon nanotubes each formations is there. That is basically the arrangements of the carbon atoms in the carbon nanotubes. So, now is the applications, so we will discuss. So, here I said that carbon nanotubes that we can form. So, we can use many applications. So, energy storage applications, there we can use these carbon nanotubes, hydrogen storage, hydrogen gas storage, there also we can apply, or some these materials we can use as a catalyst supports, since these carbon nanotubes having or possessing extremely high specific surface area, therefore, these materials can be used as a catalyst support materials also. Okay. Even sensor applications, there also we can use these carbon nanotubes as a sensors preparations or sensor fabrications, there we can use. I said that the carbon nanotubes having high mechanical strength, therefore, this can be used for fiber reinforcing elements that can be used. Also, it having strong electronic properties. So, it can be used for the means sp2 type of bond formations is there. So, in two carbon atoms. So, therefore, sometimes it is showing metallic interconnection circuits. So, where it can be used, this is one metals, this is another metals in between two connections. So, there see this type of carbon nanotubes we can fabricate, and that can use as a interconnect in that circuit. So, since it possesses metallic property, that can be used, that metallic property can be used for that circuit fabrications. So, these are the other applications. So, already a few things we have discussed. Now, the synthesis of carbon based nanostructures or nanomaterials, that is nanoparticles or nanotubes, that we can prepare. A number of methods are available. So, for when if we want to prepare carbon nanoparticles, so then these are the three methods. So, basically we can use solvothermals or hydrothermal methods that we can use to prepare the carbon nanomaterials, or microwave assisted methods, carbon nanofiber formations we can use this, or template assisted method, that also we can use to prepare the carbon nanomaterials. So, apart from that, so there are some other method also. So, that is electric arc discharge method, that we can use to prepare multiple carbon nanotubes, and in this process we do not have to use any catalyst. And CVD method also is there. So, in this method both single wall multiple carbon nanotubes we can prepare by using these methods, or laser ablation methods, that is also available. So, that method also we can use for preparation of single wall nanotubes. So, in hydrothermal methods, basically here some organic materials that you have to take as a starting materials, that we have to means treated heat treatments or thermal treatments you have to do at high temperature and high pressures, organic materials that would be converted into carbon nanoparticles that would forms. Okay. So, here these methods we can use. Then microwave assisted methods, that also can be used for the preparation of the carbon based nanomaterials. and for this purpose here we can use different bio-based resources, waste or residue that can be used for the synthesis of carbon nano based materials or carbon nanoparticles that can be synthesis. Okay. So here's once anodized alumina was taken and their aqueous beverage solutions were put, and then that was treated at 200 to 250 degrees centigrade in presence of toluene at for 6 minutes, and then microwave that was passed through these particular solvents and that mixtures, and then base treatments was done, and then carbon nano fibers formations by microwave assisted hydrothermal pyrolysis that was prepared. Okay. Then template assisted method also can be used for the preparations of the carbons nanomaterials or carbon nanoparticles. So here's some nanoporous templates that we can use, silica or zeolite type of materials that can be used as a templates where that different type of pores are present in this particular materials, and then pore would be filled with that particular source or organic materials, and after that some temperature, high temperature, that would be heated up, and then template can be removed, and once template would be removed, and then this type of means carbons nanoparticles that may forms once the template would be removed. Okay. So this way also we can means fabricate or we can synthesis well defined nanostructures, okay, by template assisted method. In this method actually there are some advantage. So here's we in this process we can control the nanoparticle size, shapes by depending upon that pores that would be developed in that particular nanoporous templates. Or even disadvantage or challenge is that uneven template dispersions and high cost and complex fabrications process in this particular process, that is the challenge for this template assisted synthesis method. And next is the electric arc discharge method, CVD method or laser ablations method. In this way we can prepare carbons nano tubes materials. Okay. So in this process already have discussed. So in electric arc discharge methods we can produce carbon nanotubes without putting or having any catalyst. We do not need to use any catalyst. So directly we can use 2 electrodes with a DC power supply, and then we have to create vacuums with the inert gas. So voltage 220 volts DC that can be used. When positive electrode is moved to the closer to the negative electrodes, or both the electrodes should be close to each other. So then an electric arc will be developed, and as a result high temperatures will be developed and formation of plasma, and then carbons that would be deposited in the over the negative electrode in the form of CNT, and then that can be cooled down and that can be collected as a materials, that is CNT. So that can be formed by using this electric arc discharge method. So here the experimental conditions. So here is the positive electrodes, here is the negative electrodes. So here electrodes we have to take as a graphites, and its diameter 5 to 20 mm, and the gaps in between these two would be 1 mm, and here's high vacuums we can create 100 to 500 torrs. So if the pressure is less than 100 torrs, so then we cannot develop CNT. So you have to maintain a sufficient pressures, helium gas pressures in this particular chambers. Okay. Currents and voltage we have to use within that range. So then when both the electrodes come in close to each other, then extremely high temperature will be developed, and then this type of plasma or carbon nanotubes form deposited over the surface. So we can collect, and these diameters of these tubes may be 0.7 to 1.5 nanometers and length 1 microns, and if it is fullerene formations, then its dimensions would be very small, less than 1 nanometers. Okay. Then laser ablations method, that is also another method. So that way we are that using this laser ablation methods we can prepare carbons nanotubes. So these methods already we have discussed. Then CVD method, CVD method is also, this method also we can use for the preparations or synthesis of single wall nanotubes and carbon nanotubes. So in these methods we have to pass a carbons containing gas over the catalyst surface, and then catalyst over the catalyst surface, that hydrocarbons, so that would be passed through this catalyst surface, that would be decomposed at high temperatures, and then the carbon atoms that would be forms inside of that chambers, CVD chambers. So, then that would deposit it in the form of carbon nanotubes over the substrate. That surface may be nickels, copper, plates or catalysts that we are using. So, over there that would be deposited, okay, hot surface. There's the carbon nanotubes would be deposited, okay. And this method is very cost effective, and that methods is very simple, and in this way we can means large amount of CNT that we can prepare with these methods. So, here you can see already have discussed means CVD methods. So, here we can take our precursors, and that would be heated up high temperatures in presence of catalyst, and then after here there would be reactions, and then the carbon formations would be there. So, once that hydrocarbons would be decomposed at high temperatures, and then carbon atoms that would be deposited over the substrate and forms carbon nanotubes, okay. So, in this cold surface here carbon nanotubes will be deposited, we can collect that. So, here in experimental conditions I said methane is the most common hydrocarbons that is used for single wall carbon nanotubes. Apart from that cyclohexanes that also we can use, and benzenes, others different hydrocarbons we can, ethane also, C2H6 also we can use. Mostly CH4 is used for single wall carbon nanotubes, other than for multi wall carbon nanotubes ethane propanes also we can use as a source of carbons. And pressures we have to use this, and catalyst I said any catalyst means iron, cobalt, nickel, platinum based metal oxide catalyst we can use for the depositions of the CNT. And for this process when pyrolysis or the decompositions of these hydrocarbons would be happens for the developments of the CNT. So, then extremely high temperatures you have to maintain for this particular process. So, this particular methods has means CVD methods has many advantages compared to the electric arc discharge or laser ablations methods. So, this method is relatively very simple. So, we can easily control the gas, temperatures, catalyst. So, in this process easily means cheap way we can prepare the desired carbon nanotubes, okay. So, here's few carbon source materials is acetylenes, CO that is the source of carbons, hydrogens and methanes. These are the only methanes that is the source of carbons for the synthesis of CNT by using CVD methods. And temperature ranges I said very high temperature you have to use 700 to 800, 1200, 1000 degrees centigrade you have to use. And see here various type of catalyst or substrate that you have to use. So, here's a few irons, cobalt molybdenum in SiO2, or cobalt nickel irons over MgO supports, or alumina silica that is the mixed oxide supports. There's irons molybdenum or iron ruthenium that is the active metals over which the reactions will take place and CNT will be deposited, okay. So, mostly these are the batch process and few are continuous process. So, single wall nanotubes means we can prepare, multi wall nanotubes also we can prepare by using these are the precursors, and depending upon the catalyst we can prepare. So, here in three different methods where the CNT can be prepared. So, that is comparison. So, I said electric arc discharge extremely high temperatures, laser ablations also extremely high temperatures we have to use for the synthesis. As compared to the CVD it is low temperatures 1000 degrees centigrade, 900 degrees centigrade we can use. So, here also CNT yield also very high as compared to other two methods, okay. But here's cost is also even this method is very low as compared to these methods arc discharge, electric arc discharge or laser ablations method. The power unit cost is very high as compared to the CVD methods, okay. And purity, if you want to look into the purity of the CNT that would forms by different methods. So, here in arc discharge and laser ablations methods the purity of CNT whatever that is forms over the surface of the catalyst, that is a highly pure CNT may forms by using these two methods. Here the cost is little bit high and high temperature, but in case of the CVD methods, so the impurity is more means with the CNT some amorphous carbons, graphitizations, these are the impurity may be present. So, with that carbon nanotubes, okay. So, yield is very high, but some impurities are present with that carbon nanotubes that is prepared by the CVD methods. So, therefore, depending upon the method, so we can prepare the carbon nanotubes. Okay. So, these are the different characterizations. So, which we can use to characterize the carbon nanotubes or carbon nanomaterials whatever we are synthesizing. So, TMCM, XRD, Raman spectroscopy, NMRs we can use, or AFM, TCA. So, TPDPRs, these are the things we can use. Many methods are available. So, for a particular specific characterizations we can get a specific informations, and using that we can analyze that particular type of carbon nanotubes or carbon nanotubes formations is there. So, thank you. So, today is up to this. Thank you.